Have you ever wondered how fast you think? The speed of thought, a concept both intriguing and elusive, has fascinated scientists and philosophers for centuries. Unlike the speed of light or sound, the speed of thought has no single, easily measurable value. It's a complex process, influenced by factors such as the complexity of the thought, the pathways involved, and individual variations. Our brains are intricate networks of billions of neurons, specialized cells that communicate through electrical and chemical signals. These signals are the foundation of our thoughts, feelings, and actions. Understanding how these signals travel within the brain is key to unraveling the mystery of thought speed. Neurons, the fundamental units of the nervous system, are responsible for transmitting information throughout the body. They communicate through a combination of electrical and chemical signals. When a neuron receives a strong enough signal, it generates an electrical impulse, known as an action potential, that travels down its axon, a long, slender projection from the neuron's cell body. At the end of the axon, the electrical signal is converted into a chemical signal. The axon terminal releases neurotransmitters, chemical messengers, into the synapse, a small gap between neurons. These neurotransmitters bind to receptors on the receiving neuron, initiating a new electrical signal. This intricate dance of electrical and chemical signaling is the basis of all brain activity, from simple reflexes to complex thought processes. The speed at which these electrical impulses travel can vary depending on the type of neuron and the presence of myelin, a fatty substance that insulates some axons. Myelin acts like the insulation around electrical wires, allowing signals to travel faster and more efficiently. The fastest nerve impulses in the human body can travel at speeds of up to 270 miles per hour or 120 meters per second. These high-speed signals are essential for coordinating rapid movements like reflexes and for transmitting sensory information quickly to the brain. However, not all nerve impulses travel at this breakneck pace. Some signals, particularly those involved in functions that don't require lightning-fast responses, travel much slower, at speeds as low as 1 mile per hour or 0.45 meters per second. Comparing brain speeds to the world around us. To put these speeds into perspective, consider this. The fastest nerve impulses travel at about 1/3 the speed of sound. That's incredibly fast. Imagine a cheetah running at top speed. That's roughly how fast some of the signals in your brain are zipping around. On the other hand, the slowest nerve impulses, those traveling at 1 mile per hour, are more comparable to the speed of a leisurely stroll. These slower signals might be involved in processes like regulating digestion or controlling sleep-wake cycles, functions that don't require split-second responses. From reflex to reflection, the spectrum of thought. While we can measure the speed of individual nerve impulses, the speed of thought itself is more nuanced. Simple reactions, like withdrawing your hand from a hot stove, involve relatively short neural pathways and can happen in milliseconds. These reflex actions are essential for survival, allowing us to respond quickly to danger. Complex thoughts, like solving a math problem or writing an essay, involve much more intricate neural circuitry. These thoughts require communication between multiple brain areas, with signals traveling back and forth across different regions. The time it takes to think through a complex problem can vary, depending on the difficulty of the task, our familiarity with the subject matter, and our individual cognitive abilities. The speed of thought, therefore, is not a single entity, but rather a spectrum. It's a testament to the remarkable adaptability and processing power of the human brain, capable of both lightning-fast reflexes and deep contemplative thought. The journey of understanding our own minds is an endlessly rewarding one. If you enjoyed this video, please like, subscribe, and hit the notification bell.